How does radar see an aircraft? Radar emits pulses of radio waves that travel at the speed of light. When a wave hits an aircraft, part of the energy reflects back to the antenna. Measure the round-trip time, have it multiply by the speed of light, and you get the range. The direction the antenna is pointing gives the bearing. Measuring speed and altitude. If the aircraft is closing in or flying away, the frequency of the returned wave shifts slightly. This is the Doppler effect. Radar uses that shift to compute the closing speed. A 3D radar also measures the elevation angle, and from it infers the aircraft's altitude. Why the far-off target is faint. The echo a radar gets back obeys the radar equation. Receive power equals transmit power times antenna gain squared times wavelength squared times the target's radar cross-section divided by 4 pi cubed times range to the 4th power. The key term is range to the 4th power. The pulse spreads over a sphere on the way out, thinning as 1 over range squared. The target reflects only a sliver set by its radar cross-section. Then the faint echo spreads again on the way back, another 1 over range squared. Round trip, that is 1 over range to the 4th. So double the distance, and the echo is not half as strong. It is 2 to the 4th, 16 times weaker. Detection range therefore grows only as the 4th root of everything. To see twice as far, you need 16 times the transmit power. And having a target's radar cross-section shrinks its detection range by only about 16%. That is why stealth aircraft must cut their cross-section by huge factors, not small ones, to matter. Real target, or clutter. Radar does not just see a bright. The system filters and analyses. Is the signal moving steadily? Are the speed and altitude plausible? Is the trajectory continuous across many sweeps? There is also IFF, identification friend or foe. Aircraft carry a transponder. No valid reply means the target is treated as suspect. Locking on. After detection, the radar does not measure just once. It keeps sweeping and updating the target's position over time. From many successive data points, the system works out where the aircraft is, which way it is heading, how fast, whether it is turning, and where it will be a few seconds from now. This is tracking. How is a missile guided? There are several types. Ground radar sends steering commands to the missile. Semi-active, where an outside radar paints the target and the missile homes on the reflection. Active, where the missile has its own radar in the nose and tracks the target itself once close. And infrared, homing on a heat source, such as the engine exhaust. Why does it hit a fast-moving target? The missile does not fly straight at the aircraft's current position. By the time it arrives, the aircraft has moved on. The system must compute the intercept point, given the current speed and heading, where the aircraft will be in a few seconds, and send the missile on a lead path to exactly that point. Proportional navigation. There is a smarter way to steer than chasing the target's current position. Point straight at it the whole way, called pure pursuit, and the missile curves into a long-tail chase, arriving from behind after the hardest possible turns. Real missiles instead use proportional navigation. The missile turns its velocity at a rate proportional to how fast the line of sight to the target is rotating. Command acceleration equals a navigation constant, usually 3 to 5, times the closing speed, times the line of sight rotation rate. The insight is simple. On a true collision course, the line of sight to the target keeps the same angle while the range steadily shrinks. Sailors know it as the collision rule. Constant bearing, decreasing range. Proportional navigation just drives that line of sight rotation toward zero. Hold the bearing steady, and impact is guaranteed, with the least maneuvering the missile can manage. Can the aircraft evade radar and missile? Yes, but not absolutely. Fly low, to use terrain masking. Stealth design, to cut the reflected signal. Electronic jamming. Decoys, chaff, or flares. And hard maneuvering, to break the lock. But modern radar and missiles have countermeasures. fusing many sensors and prediction algorithms. The console. Everything so far becomes a set of switches on one console. Watch a single target as we steer it, change its speed, throw stealth, jamming and decoys at the radar all at once, break away with a hard turn, then solve a fresh intercept on a target that refuses to fly straight. These are exactly the buttons you get next. In short, radar is like someone with a flashlight in the dark, except instead of light, it uses electromagnetic waves. The echo tells it where the aircraft is, which way it is heading, how fast. The air defense system uses that to compute a flight path for the missile, guides it to the area, then lets it home on the target and intercept. Now it is your turn to try.